Good morning, everyone. Thank you for joining us today. We are excited to introduce the ReidBar Optimised Coupler and share the journey behind its development with you all. What we'll do today is we'll discuss the key drivers for the change and why we had to do a redesign, the benefit the new design delivers to the precast and construction industry, and also how it compares to the existing coupler solution that most of you are used to. Before we get started, I'd like to introduce the Reid team that you have with you today. My name is Mina Berjani. I am the Business Development Manager for Precast. I'll be taking you through the session today. But alongside me, I have Aidan Fogelberg and Yang Han, our structural engineers, who've been quite involved in the engineering, testing, and validation of the product. Throughout the presentation, please feel free to use the Q&A function, put down any questions you may have, and Aidan and Yang will do their best to answer most of them. We'll also allow some time towards the end of the session for any interesting Q&A for them to share with everyone. If we do run out of time and you have more questions, I encourage you to take a screenshot of what you see in front of you now, as you can reach out to any of us after presentation or any other time, just to help you out with any query that you may have. So just a little bit on what's on the agenda today for the next 30 minutes. What we'll do is we'll talk about the journey of the ReidBar coupler and why we've had to optimize the coupler. We'll just touch base on the enhancement and the key design changes, installation benefit that brings to you, a little bit about compliance, the product range that we have available at the moment, and a little bit on technical resources, and we'll wrap up with Q&A. So this ReidBar coupler has been on quite the journey, as you may all know. The ductile cast iron original coupler was launched around 2007, and up until 2018, it actually enjoyed being a mechanical splice system. This design provided a fast, simple, and reliable reinforcement continuity for the market. Then 2018 happened, and changes to the NZS 3101 2006 Amendment 3 was introduced that stipulated that cast anchors and couplers are not permitted. That became effective in November 2018. So as you can imagine, the R&D at Reids were very busy, and we managed to launch, as a reaction to that and to ensure compliance, the steel coupler range alongside the epoxy. So the epoxy filler was introduced, and that is to support the connection to resistant to slip under cyclic requirement and cyclic loading. So we do have a compliant solution for the market to use. Then from 2019 and going forward, we've noticed that the changes and the standard has increased the steel requirement, created congestion challenges at precast panel. And that feedback continued to occur the few years after, and it became evident that we really do need to refine our current ReidBar coupler to create a new design that is more compliant with new and modern construction practices, as well as be compliant to the industry standard. And that's what brings us today to the introduction of the ReidBar Optimised Coupler. So just to touch on the feedback that we've received, the ones I was mentioning, is the first one is the coupler being too long. And when you have a fitting that is too long, that can reduce concrete cover within a precast panel and create installation issues. It was not uncommon for when we walk on precast yard, we notice that the coupler has been installed protruding out of the panel, which is 100% not ideal. So that was definitely on our job, is to design a shorter coupler so that it can provide a better cover. The second pain point is the reinforcement congestion. So large diameter of the coupler was always been sort of the feedback that it was too large, and that was creating congestion within tight bar spacing, causing clashing with reinforcement. So the second objective was to create a coupler that is smaller in diameter to address this congestion issue. So our innovation objective and design intent became to redesign the ReidBar coupler by optimizing the component's length and diameter whilst reducing material use. And with that, what we wanted to deliver to you is a simpler installation, less steel congestion, and also improved cost performance. So ta-da, now we get into the nitty-gritty of what the new coupler is. This is the marketing reveal, as you all know. So what we do, we're going back to the first problem and addressing it. So that's to do with the coupler's length. So we have shortened the coupler. The new optimized coupler is shorter in length. And you see there is a comparative table here. So if we were, for example, to pick the size 16, you'll see the original coupler was 136 long. The optimized coupler is 110. So that's a reduction of 26 and of 19.1%. So across the overall range, you'll see that an average reduction in length is about 17.3%. The largest significant reduction in length is seen with the size 32 being 58 reduction. Similarly, when it comes to the diameter of the coupler, we've reduced the diameter across the range. And again, if you look at size 16, for example, the original diameter is 32. It has reduced to 26. So that's a reduction of 6 and 18.8% reduction. Across the range is about 15.4% in reduction. 10 millimeter reduction in diameter is seen as the maximum in the size 12. So here a visual to demonstrate the difference showing between the existing original coupler and the new optimized coupler. As you can see, the percentages of the overall volume percentage between the two. Now, what has changed? So we now have a shorter coupler, reduced diameter, and we've optimized the material use. However, the same required connection performance is achieved. Wanted to talk a little bit about installation and the benefit it delivers. Now, the step-by-step installation you'll see in the product guide is the same as the original coupler. However, there were 3 points I wanted to highlight today that are different to the existing coupler. Number one, we're saying it's cheaper, and that's because the optimized design reduces the epoxy consumption to about a third. So you are using less material, so that saves cost in material and also installation time. If we were to pick an example, size 16, the existing coupler requires 3 pumps versus the optimized coupler requires 1 pump only. The second point we wanted to highlight as well is a new geometry. So another notable change that you'd see is the hex section has been moved to one side of the coupler. That's the intent of that originally was to strengthen the center zone of the coupler. However, as a nice side effect, the socket can now fit over the coupler, so it makes installation easier. It's also important to notice that the coupler can still be installed in either direction. The third important benefit is the easy QA. So thanks to the Ramset brand and their recent launch of the new epoxy, the Epcon G5 Extreme, it's got a very bright orange color. That is very helpful in qualifying that the epoxy has in fact been installed and the adherence to the project specification has been achieved. Now, moving on a little bit about compliance. So there is one takeaway is that the optimized coupler system continues to meet the same key requirement as the current original coupler. So even though we have a smaller coupler, we have a shorter coupler and more efficient. However, the performance requirement has not been compromised. More specifically, the system is qualified to satisfy the relevant requirement for mechanical reinforcing connection under the NZS 3101 Chapter 8, along with applicable requirement of the NZTA Bridge Manual. Now, still remains a key part of the system is the use of epoxy filler within the threaded connection, which supports the connection cyclic performance, including both low cycle and high cycle fatigue requirements. Now, for those of you who are more interested in technical information around testing behind this system, feel free to download the RTA document that we have in our website, the Reinforcing Technical Assessment, if you are curious, or you could reach out to Yang or Aidan for some more information. Now, moving on to the change to the SKUs and the codes of the product. So what you see in front of you is the black finish. So the optimized coupler does come in black. It comes in the same size range, 12 to 32. The change in the code is from the CS that we had in the original coupler is replaced with SCP. That is the main change. So as you can see, say size 12, it's used to be called RB12CS. Now it's called RB12SCPB. The second finish, which is the galvanized finish, similarly, we've stuck with the same size range, all available in galvanized. The code replacement is the same. We've replaced SCP with, CS with SCP. So as a size 12, RB12 CSG is replaced with an RB12 SCPG. Now, all of the sizes are available in black and galvanized. Just a note about commercial is that the coupler component for component definitely more cost effective. So the optimized coupler is more cost effective than the original existing coupler. It's also important to mention that our ductile cast iron range of coupler in both black and galv will be discontinued in all sizes, so they'll no longer be available. So just a bit of a summary and a wrap-up of what we've discussed. So we now have a new design, an optimized solution that addresses satisfaction gaps that is identified from customers, reduced body length that improves the precast installation. We've reduced the outside diameter that improves congestion challenges. We've got raw material changes that delivers optimized design with no performance impact. The Epcon G5 Extreme provides an easier visual assurance. We're still using the same existing nail plate for simplicity. Range is available in black and galvanized and is more cost effective as the existing coupler. We've got resources available on the website for you to download to support you with technical specification, with installation, and so on. So you've got the optimized coupler product guide. You can download that and it has the same information. Currently and temporarily, we have a standalone Epcon G5 installation guide. So when you open the guide now, you probably see Epcon C8, but if you scroll down, you'll see there is a standalone document regarding the G5. And we also have all our BIM models available for your download, and I can't reiterate enough the importance of updating your library with those. It's important. And also the RTA documentation for those who are interested in more technical information, all available for you to download. In addition to all of that, again, I want to mention you can reach out to any of your Reid team, to your account managers, if you need anything else beyond what you have. Just one thing to consider, and I just thought it might be important to explain that in a little bit detail. We've summarized now the product and what's available. Just wanted to focus on a point that I believe is quite important. If you look at the orange, the diagram with the orange, that's your original coupler. And if you just really zoom in what's inside that red circle, you'll see that there is a step. That's the original design, has got a little step. And what that step does, it stops the bar from threading all the way in to the blind, to the stopper. So you are meant to have that gap, which is normally filled in with epoxy. In comparison to the green, which is the new optimized coupler, so not only the coupler itself is shorter, but also that step is no longer there, which means that when you install the bar, it goes all the way into the blind spot. So that really affects your installed bar length and your cut length, some of you call it. And the only way to make sure that you get this right is to use the BIM models available to the website. So use that, download it so that you could avoid changes, because the installed bar length will vary. Sometimes it's longer, sometimes it's shorter. So that's very important to note. And just in case, just to cement that message, Young's been very kind to help me with some animation to share with you today. This is a typical connection setup that you have. So what we have in orange, the original coupler that you have with the usual setup with bar length on both sides, etc. Now, if we were to stay with the same detail and just replace the optimized coupler, you can see here that you're going to end up with a small gap. Okay, now remember, with the optimized coupler, we cannot have a gap. It's not designed to have a gap. The bar needs to be threaded all the way in. So, and then obviously the coupler itself is shorter. So we need a longer bar in this case. Similarly, on the wall to suspended floor connection on the starter bar side, you could say, if we stick with the same detailing and didn't update our BIM models and use the original coupler, that's what you'd have on you. And if you were to replace it with the optimized coupler, you will have a gap. There is a small gap that needs to be filled. So you do need a longer bar to go all the way in and fill and installed as per specification. So just really wanted to hone in on that point, because it's quite practical installation, and we don't want anyone to come up against that challenge sort of down the track of the project. So I hope that was helpful. That's really all from me today. Thank you so much for joining, and we will come into our Q&A section where Yang and Aidan will have a look if anything had come through to share with us. Otherwise, you will receive an information pack with links to the website and so on, and you can reach out to any of us at the after the session or going forward. Thank you.
Thank you very much, Mina. If anyone has any questions, feel free to just drop them into the QA section. We'll highlight a few of them, so you'll be able to see them in the published zone. So first question we had was, does EPCON G5 replace C8 Extreme? Which I have answered yes. So EPCON G5, that's Ramset's new pure epoxy. It is set to replace EPCON C8 in future for all connections of this type. So any mechanical splices for reinforcing, so all I-port flange anchors, for example, these optimized couplers as well, those will be using G5 in future as well, and C8 will eventually not be available for purchase. Oh, I think we've gotten away pretty lightly. Any other questions out there, folks? Feel free to add them into the chat. We do have one more in here about the discontinuation of ductile cast iron couplers. You might be able to answer this one as well, Mina. Of course, yes, they are being discontinued with the introduction of these optimized couplers, as they are, more price competitive. So they're seeking a date for that. Now, I understand that we're looking to sell through. I don't think there is a defined date at this point of time. So
Yes.
That's all the answer I have at this stage for that.
Yes, I can double check that, but as far as I understand, is just while stock lasts, pretty much. But I can get you a more defined date. Thank you for the question.
But we have, oh, here's another one as well. Young, did you want to answer this, or shall I take it?
Sorry, I'm just reading the question here. So what we have to do if the original structure drawing by client showing the older coupler details? Currently, I think that's better to reaching out to the client about, with the older coupler details. And also when you're doing your shop drawings, right, you wish to using our newer details, so you actually can have a actual measurement on the bar, the cut length of the bar. And of course, you are not sure. I think just double checking with one of our team as well, see what would be the change, because I think it will actually vary based on the size you put it in. Because sometimes people on site, they were being delivered with a precast component. They probably don't know what coupler being using in the panel. So yeah, it's better to double checking on that, and then make sure you get the bar to the right length as required.
Absolutely, and I will say for the precast side, what you guys will be experiencing with this, as Mina discussed, the only key difference in terms of installation will be a slight difference in bar length for that one, because of course these couplers are quite a bit shorter, and that depends on their relative position in the precast element. But of course, all the BIM models, all the dimensions, that's available on our website. We try to make sure as many people are aware of this as possible, especially drafters, but the message, of course, is quite hard to get to everyone. So if there's any concerns, feel free to send them our way. The details are available online too. So if there is any concern around that, we encourage you to send that information through first and foremost. We've got another question here about using C8 in place of G5 for optimized coupler connections. Yes, so we have an RTA document for the use of C8 with this product as well. So the optimized couplers can be used with either G5 or C8 if you do have stocks in place. That's not a problem at all.
Through our stock, can we still use a hybrid combination of those coupler? I believe what it means is, well, if you have one single bar and you're actually splicing one older coupler and one new coupler at the same time, yes, which you can if you wish to do that. Yes, the answer is yes.
Exactly. All the key performance characteristics of these systems are identical between the two.